let's see. I'll pull up the NASM documentation. Oh. We can do some printing. Oh. All right. It would be fun to do some macros, but let's do some printing. So I started a video, a printing thing. Gotta find it here. There we go. Oh, this will print off lots of bits. And I decided to try a conditional move, which was interesting. So probably should do make. Printed off lots of bits. So here we've got prolog. Save my used registers. Here's my initial bit mask. So I did it so that this one is doing the top bit. I didn't really want to do that in binary. That's just a lot of bits to type. It's like 64 of them. Probably could have done a left shift on it. That was for testing. Alright, so here is as the Linux, RDI is arg1. Move arg1 to R13. So I need to save it because I'm going to destroy RDI here. So R13 is going to be argument 1. So let's see how if we did a macro. Nah, let's not do a macro yet. Let me comment my code and then we can do that. Maybe I can compare some other things. All right, so R13. No, I'm not sure. Does this their function macros? Standard macro packages. That doesn't quite. I'm not sure what that is. Windows, that would be awful. We'll have to do it, but. Function definitions and function calls. Yeah, it doesn't let you rename them. Anyway, okay, let's just go on. So R13 has our value. We're going to keep it there. So we're going to copy RDI into that. R14 is a counter saying how many bits have we printed off. When we get to 4, we put a space. So I set it to 4. Every time in the loop, I subtract 1. When it's 0, we will continue through this jump. And then we'll move a space into RDI, call printf. So space is defined as just a byte that has a space. I could probably use put character. That might be better. Probably less overhead than the other. So oh gosh. Why do you do this to me, YouTube? Okay. I don't know what Restream's deal is. It says that nobody's watching, but not sure that's true. Okay. So we copy R13 into, so we kept R13. So R12 is going to have our mask. I'm putting that in. I am ANDing that with this, with R13. So I've got 1 bit set. So if we kind of conceptually look at this, I've got, say, R12, and it's got, say, a bunch of zeros, and then it's got a bit set and a bunch more zeros at any point in time. And then I'm taking RSI, and it might have, you know, whatever. And then if I AND these two together, it says, do they both have a 1? So in this example, right, it doesn't. So the value that gets set in here will be, in this example, let's see, we're doing RSI. It's going to have basically all zeros. But if RSI, we take this whole thing again, and if it so happens that the bit that we picked matches, the output that we get is going to be a 1 in RSI. If we AND it with R12, so we'll get either we get 0 or we get not 0. And so if we have that, then when we do our conditional move, so we can conditionally move a 1 into, or a 0 into RDX. And so what we do is we say, okay, if we're going to set RAX to 0, and then if the result of this operation was a 0, I'll move RAX into RDX. Move a 1 into RAX, and then if it's not 0, I move this in. So what I basically have here is an if without coding an if. Right? I actually originally wrote this as something like compare RSI to 0, and then saying jump not 0. JZ. Then I had one that was 0, 1, and actually you could do jump not 0 to 1. And then this one was over, say over. So I can jump over, jump to over. This one can actually fall through. And then I would move into RDX 0, and here I would move RDX 1. So this adds lots of labels, and I decided I didn't really want to do that to do all of this. So the gist of it is that I can get rid of all of that and replace it with basically 4 instructions to move my different, I'm moving my different registers, putting values in them, so I'm using RAX for both. And basically only one of these is going to get executed, either this one or this one. It's either 0 or it's not 0. And conditional move means it's only going to do it if it's one of those. And then, so RSI has how many, so in this printf, you can say how many sort of spaces you want. So I put that I wanted 1 space, so we can see the output if I do 1 space. And let's change our main. So here I was just doing it a bunch of times, but we don't have to do that. We can print our bits. Make and so this is C, A, F. Okay, this is the other stuff that's not in there. That's other stuff being tested.
Oh, it's a controller. It's a controller.
Wait,
I won.
wait,
I
who
think
won?
I won. I think I won. I should have won. I think I won. I should have.
I don't know why it started that. Not muted, of course. But oh well. Okay. So I don't think I changed anything in this one. All right, so we got our moves. And this is saying how many spaces. So here we can see that we've got 1 space. If I put a 2 in here, the way that printf should work is it's going to add more spaces, actually to all of them, which is annoying. So I don't know why. I probably didn't need that. I could probably take that out, and then these moves would be into RSI. So if I took that out, instead of RDX, it would be RSI. Because RDI has our format. Then I have to modify this print format to say I really only want a %D. And it should only be a 1 or a 0. So, yeah, that simplifies things a bit. I think I like that. Okay. So, RDI, so I start at the bottom, right? RDI has to have my format. RSI is my first argument, which I did conditional move, either a 1 or a 0. The printing is doing printf, which is probably overkill. Could probably print a character. In order to do that, what would be that? Put C? Probably. Yeah. We could do that. And then here we're shifting, R12 has our bit mass. We're shifting it over 1 bit. So I'm just going to draw the top bits in binary. So this is what it initially looked like if you shift it 1 bit to the right. Then the bit moves down, so this is the bit I will check, right? So if I just start here and I check each bit, if I get a 0, I print off a 0. If I get something that's not 0, then I print off a 1, because I know it had that bit set inside of it. And so I didn't want to use, I'm sure there's probably a printf method to do this, but I like this way. So that's R12. R14 is our counter. I talked about that earlier. So R14 is doing that. So it's for our doing our space. You know, I think it would be interesting. So let's see. If we wanted to use putc, let's look. So I think it's putc. We'll print off a character. So it should have a lot less overhead. Let's just, that's our original. I don't like destroying things, so I'm actually just going to copy this and I will put it in ASMIO. That's our first version. And we'll just call this B. Back up. Doesn't matter. I'll probably end up replacing it. So if instead I use put character, I don't need a format. So instead of RSI, I get to use RDI. But instead of a 0 and a 1 as a number, I need the characters. And then this should be put C. And then RDI in this one should get an actual space. I think it's, is it put C or put car? Put C sounds right. Yeah. So let's see. Oh, yeah. Space and format bit are not defined, but they can be moved. That's in my library function. And default rel symbol space print bits line. Oh, I probably used them. So I have hex. Let's see. 38 space is not defined. Yeah, because I moved it. Space. Let's just, we'll have them both places. I didn't need to, I guess, delete them. And I broke it. Oh, perfect. Oh, let's see. So I was guessing on this. RDI should be my argument. Print bits 122. Oh, I don't need an LEA. I need a move. Well, let's look at an example. I don't need you guys. Let's see. Now does putc take Oh, see, that's why maybe put car. Oh. What is put car? Put car, put car, put car. Yeah. And I put a string in there, so in C, I need. Yeah, that puts it. So let's do put car. That's better than. All right. And I don't call my. I took off my normal stuff. Let's put that back. So we will put that back. Call it. And we got nothing. Perfect. Well, it printed spaces. I don't think it liked RDI. Oh, I don't know what I was. I don't need that. There we go. It's probably faster. Printf is maybe not the greatest. All right, but we can see that, that gives us the ability to print off all of our bits here. The other one that I was working on was printing off the hex values. So here we go. So this one does use printf, and it's using the hex format. Again, telling it how many spaces to put. And we could put them both together. So we could call print hex after we call print bits all the time. So print bits could just say at the end or here, print 64 hex. And they would always sort of print together. Now this one, I think you need to put how many spaces you need in. Yeah, RSI has to be 4. For it to look nice, and then move RDI. And actually, if I do, well, where are they at? I think our original is here, so R13. So move RDI, R13. And then we should be able to call print hex and then restore. And we get the hex along with the binary. So the hex is similar. So instead of using 1 bit, we're using 4. So F has 4 bits. Here we are. So RCX is how much we're going to shift by, and we actually have to use CL when we do a shift. You can't specify a larger register, which that's got enough bits to tell us how many to shift over. You just need a number between 1 and 64 that you want to shift. Again, R13. So this one, R13 has our mask. Our original is an R15. And you can use all kinds of registers. I am liking R12 to 15 because I don't have to save them when I go and call printf. Otherwise, you'd see a bunch of saves in there, which is kind of a pain. And I don't really like that, so don't think it's quite as nice. So let's see, what are we doing? So R13 is our mask. Again, we do an AND of it. And then, so the reason it has to do a shift is it needs to take this byte here and move it clear down here so that we can go and print it. And our print is going to print the hexadecimal version with so many spaces in front. So the number of spaces is, so RDI, RSI is what we pass in. So RSI has the number of spaces we want. RDI has our format. Again, use LEA. So if you do a move, you get a warning when you compile because it's not position independent code. So to get rid of that, do an LEA. Load effective address. We'll get the address, which is 64 bits, and then put it into RDI. Here we're saving RCX. So this is our loop counter. Sorry, this is our shift counter. See, it starts here. And then we use our format, call printf, and then we want to print a space in between. And then if you really want to, you could do a check to see if the number of spaces, if it's 0, we could just print the hex value of that version. But that's just like a, I think, did I do that? I did print it. I don't think I did a print hex, but it would be just like a print int. Which, if you wanted to do that, right, you would take, let's say, print int. You can make a function called print hex. And instead of this print int, %0, and we want 64 of them long x. So we want it in hex. Copy my format. Print hex would be, there we go, the print hex format. We would want to export it. Global print hex. And then in the include, and then if you just wanted to call it, you could, you know, you could call it, you also declare it. Print hex. Let's see, where did that? Oh, that messed up some stuff. Where did I call that? Oh, this probably uses RAX. These are my non-standard functions that I wrote. Oh, and I don't need 64 bits. I need 16 hex digits. So that should be... That's not bits, that's 16. I should have known that. There we go. Yeah, I don't know which one you guys like better, you know. I can probably take out this print 64 hex. Because our print bits does the same thing. Let's see. Let's pick a different constant. Those are boring. A, B, B, C, C, D, D. I mean, they're not boring. They're fun, but... So you see A is 1010, B is 1011, C is 1100, D is 1101. The ones that people usually don't get are like E and F. Well, E. F probably not so much. F is probably pretty... F is all ones, which is pretty easy. The ones I usually forget are B, C, D, E. I get A, but yeah, the rest are a little different. So yeah, I think that's that seems to be working pretty well. And we're using putchar, so we can add this to our standard library. Print 64 hex. So let's put that down here. And put it at the top because I was coding it. Wanted to see my format. And I did try and do these as sort of standard functions, right? So using RSI and RDI as my first two arguments. I used to do a lot of stuff where it was not that way. Just because it's easier to move something in DAX and do something if you just want to mess around. I'll need to grab what? Hex format and space. Oh, wrong one. All right, hex format. Okay, print bits. Okay. I just need hex format and space. Okay, so this is our standard 64-bit. Here's our hex format. I don't think I need format bit. Print new lines here. Yeah. We're using putchar. We will have to say extern putchar. Yep. I need to make these global. the include file. They are extern. That looks good. Okay. So we should be able to make our project. Make a terminal. Okay, make. I did that right. Look at that. Beautiful printing. Prints it all nice and neat for us, so we can see it. And you know, you might want to do another call, print NL for a new line. I do like doing make and then running the program, so if it succeeds, it will actually just run it. If it doesn't succeed, it will not run the program, which is awful nice. So we can see all of our bits that were in our register. The register that it uses by default is RDI. So I think that's good. And if you cared about it, you'd push RDI, pop RDI. Question is, will that work? Nope. Right? Because we have to sub RSP by 8 or push something else. And then the stack alignments will be all super and proper. And it'll work. So if you cared about it, you got to do this, or just push it twice. I don't know. That seems weird. Seems like a not fun part. I don't care about it, so it can go away. Save myself a few micro operations. So not seeing anybody listening right now, so I think we kind of did what we set out to do. So I know that people say like and subscribe, so if you like the stuff, you're welcome to do that, and we'll do more streaming hopefully tomorrow. All right, we'll talk to you guys later. Bye guys.